Hello, and welcome to North Green Security's video about what is port scanning. Port scanning is an incredibly fundamental task within penetration testing, but it can be overlooked when people are first starting out and learning how to conduct a penetration test and understanding the steps that are required within a penetration test. Port scanning is one of the fundamental first steps within any attempt to assess a computer and identify methods to attack. First, get an understanding of what ports are, and then how, as penetration testers, we can take that understanding and launch port scans. When we're talking about port scanning and the ports that we're looking at here, we're not talking about ports like an Ethernet port or a USB port or anything like that. We're not talking about the physical hardware of a machine. Instead, what we're thinking about is a logical port. When a computer is interacting with another computer, they need to have some understanding of how data is going to get from one machine to another. This is done through the use of ports. Example that everyone should be familiar with: whenever you connect to a website, whether it's Google, Instagram, Snapchat, whatever it might be, whenever you connect to a website, what happens is your computer is not only going to the IP address of that machine, but it is going to the appropriate port of that service. And what that means is that for someone like Google to have a website for you to go to, they are running a web server on a port that you can connect to. When you type www.google into your browser, you are actually telling your computer to go to a specific port on the Google server. That is where the web server exists. That is where the website exists. And it means that you are able to interact with that machine and you are able to load up their website in your browser. Now, if we try and get an understanding of that, if we think every kind of machine could be thought of like a house. We've got a street, that might be our network. We've got a building with an address, that might be the IP address. And then we've got a series of windows and doors that we can think of as representing the different ports that exist on that computer. Just like with houses, where some houses have lots of windows, lots of doors, some have fewer. So when we think about this picture here, we can see we've got a building in front of us. If we were to go and try and speak to someone inside that building, there are a couple of different ways that we could try and do that. We've got the ability to turn around and say, there's a front door. We could go and knock and see if we could talk to someone. There's a garage door. We could go and bang on the garage door, see if someone would open it and talk to us. There's a second garage door, and then there's a variety of windows. There's lots of ways that we can interact with someone who is inside this machine. And this is a really good way to try and think of a computer and its ports. When a computer has a port that is open, that means that we are able to interact with that machine through that port, and it is a service that it is providing. So when we're talking about ports, what we've got to really be aware of is that there are two main types of protocols that different ports on a machine can use. And that's TCP and UDP. TCP being the transmission control protocol, UDP being the user datagram protocol. Now, it's important to understand the difference between these different protocols because they get used in very different ways. Okay, they've got much different use cases. TCP is for when you need to make sure that data has reached its intended target. It is accurate. You need error checking. You want to make sure it's been restructured properly. UDP is when you just want to send a large amount of data and send it quickly. Some of the easiest ways to think about this is to think about TCP like a phone call, UDP like sending a postcard. When we make a phone call to someone, we have to put their number in, and then the phone rings. Okay, that is our ability to try and interact with them. It is only going to be a successful interaction if they are there and they pick up, and then we can start talking. Whereas when we're sending a postcard, we just send it and we hope for the best. So let's think about that. Having a phone call means that we phone someone, we say hello. The reason we say hello is to confirm that that person is there and they have actually answered the phone. There's no point going into a conversation just because the phone stopped ringing. It might have hung up, it might have started loading an answer phone. We say hello to be able to say, are you actually there? We get a reply from the recipient, they say hi, and then we can start our conversation. Then we can say, hi, how are you? Now, what this means is that we can turn around and understand this is the general structure of how phone call works. The person initiating the phone call gets confirmation from the recipient. When you try and go to Google, your computer in the yellow here sends what's called a SYN packet to Google or any other computer, any port that you're talking to. It sends a SYN packet. It's a synchronized packet. If that computer is able to be reached and the port is open, they send back a SYN-ACK packet. That is a synchronized acknowledge. You then turn around and acknowledge their acknowledgement, and the communication could start. This is called the TCP three-way handshake. It is a fundamental in computing, and it is how all TCP ports are established. Okay? Anytime you connect to any TCP port, it will start with a SYN, a SYN-ACK, and an ACK. If you are not able to get to that port, if that port is closed, if the server is not running the service that you would like to interact with, you will get what's called a reset packet. Think of it like someone didn't answer their phone and it went to their answer phone. You will get a reset packet instead of that synchronize acknowledge. That means that your computer knows they cannot talk to the service that they want to. And this is, again, how every single TCP port has to work. So let's think about UDP. UDP, I mentioned, was our kind of put it in a post box, hope for the best. This is because UDP doesn't have anything like a three-way handshake. UDP can be thought of with the phrase fire and forget. You are sending data and you are just hoping it gets to the recipient. Now, you may be wondering what kind of communication would anyone ever want that to not know whether or not the recipient has received the data that you sent. But let's think through what a good use case would be for just being able to send data to someone. When we're listening to music, streaming movies, that is a lot of data going across a network, going from one machine to another. Every single frame is going to be represented by different packets of data coming to your machine. A packet is how the data is going from one computer to another. It doesn't come in one big chunk. You are getting a constant stream of data. Now, if you're using a protocol like TCP that has error checking, that makes sure that all the data has got to you before it tries to do anything with it, then as soon as your network drops one packet with one frame of that movie that you're watching, everything's going to stop because suddenly there's an error. But you've got to think, when you're listening to music, when you're streaming videos, if there's a glitch, if there's really simply a drop in quality for a split second, you don't notice it. You don't want the whole thing to stop so that you can go back and get that one split second worth of data back. You want to be able to just keep going. This is how UDP works. It is about data streams as opposed to being able to get a piece of information. Typical use cases for TCP and UDP might be UDP for something like video, where we're just constantly sending data and we don't want the overhead of constant back and forward communication. Where at TCP, we might do something like an email. If we send someone an email, we want them to get the email and we want them to get the email how we intended it to be structured. If we've attached a PDF to that email, we want all the data to get to their computer, and then we want their computer to understand how to recompile it back together into a legitimate PDF with whatever text we had on there. So there's ways we can think about TCP and UDP that way. The reason it's important to be aware of those is because when we think about port scanning, And when we think about what is port scanning and why do we do it, we've got to build all this knowledge into a process. So we now know there are ports on computers. They act as ways for us to interact with a machine. And there are TCP and UDP protocols that get used. Now, when it comes to port scanning, what we're doing is we're saying, I know that these ports exist. I know what protocol they might be using. What I want to do is I want to test every single port, and I want to be able to find out whether or not that port is open. Okay, when I say open, ports can be in two states, open or closed. If a port is open, we can interact with it. If it is closed, we cannot. Port scanning. The goal we have is to identify running services. We want to identify them because that gives us a method of interaction. And if we can interact with a port, then we may be able to attack it. If we think about a house, we have the doors and the windows that give us some method from the outside of interacting with people, services, whatever it might be on the inside of this house. What we can think about is that these would be the ports and these would be how we can interact. Now, from our perspective right now, we can see that we've got a front door, a couple of garage doors, and a couple of windows. The reason we do port scanning is to get the true understanding of the attack surface. Now, what the attack surface means is, what does it actually look like when we're trying to figure out how to break into something? What are the actual avenues of attack that are available to us? If we were a burglar looking at this house, we wouldn't want to just look at it from the front. We'd want to be able to go around the back. Is there a garden with a fence? Is there a back door? Are there windows that are open at the back? Is there maybe a first floor balcony? We'd want to get a good understanding. How could I break into this house? Port scanning is fundamentally no different. Once we know a computer exists, we can turn around and say, I would like to scan every possible port that could be open because I want to understand which ones can I interact with. There may be ports that we are not familiar with, that we have not tried to connect to, that are available to us, and we just need to figure out what can we do with that. The benefit is, as with all computing, everything is structured and defined. There is a finite number of ports that we can interact with, and that is 65,535. For anyone listening who wants to be pedantic, technically you could define it as 65,536 if you factor in port 0. But what we've got to think of is that we can then turn around and say, okay, I've got my house or my computer. I'm going to check to see what is every possible potential attack pathway into this by checking all 65,535 TCP ports and 65,535 UDP ports. That's also an important distinction that we'll get into shortly. The idea that when we are port scanning, because there are those two key protocols, we scan both of them. Different services are being used on different protocols. Let's talk about how to use Nmap. Nmap is an industry standard tool. Nmap is a phenomenal tool that is used as a network mapper. Okay, Nmap is the go-to tool to be able to turn around and do port scanning against whatever target machine that you may be interested in. There is a lot of capability with the tool Nmap. There is a huge amount of different activities that we can undertake with this tool. So we're going to jump in and have a bit of a look. Okay, so here we are in our Kali VM. What we're going to do is we're going to run through a couple of the key activities that you might do with Nmap so that you can understand how it works. Okay, so first of all, what you can think of it is how do we interact with Nmap? We can simply type the word Nmap. If you want to know everything that it can do, by being able to just type the word Nmap and hitting enter, get all this information about the different flags you can use. Now, when you hear anyone say the word flag, what they mean is an option within Nmap. So, for example, this is a flag. This is a flag. These are different flags. They are just different options. And we can see that when we just press Nmap and anything else, it gives us a good amount of information. It gives us an ability to understand how we can use the tool. If I scroll all the way to the top, we can see we get different kinds of scans that we might want to use. We've got information about how we specify ports and scan order, how we can do version detection, commonly referred to as banner grabbing. There's lots we can get on with here. Okay, so let's think about some of the activities that are key for using Nmap. Now, while we are talking about port scanning, first thing Nmap is helpful to do is to go through the process of what we call host discovery or host identification. It's about being able to know, is there a computer we to interact with? What computers are there on the network? And the way that we can do this is we can run a simple ping sweep of our environment. Okay, to do that, we can just do this command here. And what this is going to do is it is going to take this flag and say, I would like Nmap to run a ping sweep of my network. That IP address range is my Wi-Fi network. And so it's going to ping every computer from .1 to .254, and it will check to see whether or not it exists. You can see we get this output, and it's going to tell us which hosts exist. One of the important things to be aware of is that this has gone through the process of using ping to identify machines. Not every computer has to respond to a ping. What's going to happen is any computer that has been set up to turn around and say, I'm not going to respond to ping, is not going to be in this list. Because I'm on the same network as my target machines, what I can do is I can run the exact same scan, but you'll note I'm running it with sudo privileges this time. What that means is that Nmap will turn around and say, if my IP address is the same as the IP address of my targets, I'm on the same network range, use the ARP protocol, the address resolution protocol, instead of the ICMP protocol, the protocol used for ping. Now, this is, again, going to look at every IP, and it's going to try and find all the live machines. If you're not familiar with the difference between ARP and ICMP, we'll be coming up with future videos about that. But what the eagle-eyed amongst you may be able to see is that this machine here, 192.168.1.75, is showing as up, as in it's turned on. I can interact with it. If I scroll up, that was not here. We've got .74.83. There is no .75 in this list of output. And that is the difference between machines that do and do not respond to ping. So it's one of those things. ARP is the best protocol to use for host discovery if you are on the same network, but it does not work if it's an external network. You can't ARP scan something in a network that you're not immediately connected to as well. So be aware of that. What we can do, if we want to be able to identify machines that are blocking ping and we can't use ARP, is we can turn around and run the command to say, launch a scan against machines without pinging them. So you can do nmap pn to say, I don't want you to ping these machines. And instead, I'm going to give you the IP address range of my network. Now, if I run this, because I've told it not to do ping, it's going to take a long time because it's going to do a port scan against every single computer. What this is doing is it's turning around and saying, I'm going to check all the ports against 192.168.1.1 to see if they're open, regardless of whether or not that machine exists. I'm going to send the data to that IP address. If it doesn't exist, I'll get back errors. Then I'll move on to dot 2 and dot 3 and dot 4 and so on and so forth the entire way through this network range. So this kind of scan will take an incredibly long time to do because we're no longer as focused on a host discovery activity. We're more doing a port scan and circumventing that protection of firewalls blocking our host discovery. So I'm going to kill that because that would take a long time to run anyway. So now we know that there are computers in our network. We're going to want to actually scan them. We're going to want to find out what ports are open. And there's a couple of different ways that we can do this. Just going to go through the most common. So to start with, the most common is what we call a TCP scan. Okay, the flag is that hyphen lowercase s for scan, capital T for TCP. What this means is this is going to do a full TCP three-way handshake against the ports. Now, in the name of speed, Nmap by default will only look at the most common 1,000 ports instead of all 65,000. So that's the most common, not chronologically 1 to 1,000, because there are incredibly common ports that are, much higher than that value. It is the most common 1,000 ports. So if I give this the IP address of a machine on my network, this is now running a TCP scan against each of the ports on that machine if they are part of that most common 1,000. And we can see what we get is this response here. We get this information back saying, okay, these are the ports that are open. We get a port number. We get a state. Yep, these are open. These are the 6 ports that replied with a SYN ACK to our SYN packet, and we get the service that is running on this port. Now, it's important to be aware that service is defined by the port number in this output. It has found that TCP port 21 is open. Port 21 is the default port for FTP. Therefore, Nmap is saying this is FTP. Until we interact with that service, we can't be 100% sure that it's FTP. Most people keep services to their default ports because it's easier. It means that computers are able to almost intuitively connect to the service that they're trying to get to. And also, as we can see, if we had something like FTP, but we wanted to hide it and put it on a different port, it doesn't stop people being able to see that that service is open. It would just mean they'd have to port scan the machine and find that it is there. So this is a TCP handshake, sometimes referred to as a full connected scan, but ultimately this is a TCP scan. Now we can also try a SYN scan, sometimes referred to as a half-open scan. What this is going to do is the first 2 steps of our 3-way handshake. Okay, so we will send a SYN packet. The machine will send a SYN ACK packet if the port is open, or a reset packet if the port is closed. And regardless of what we get, we will not send that ACK packet back to the open port. We don't care. We're not trying to connect to the machine and to the service. We're trying to figure out if the port is open. So this is a slightly faster way of being able to scan. One thing to be aware of, you will need to do this with escalated privileges. And that is because we are manipulating how the TCP protocol is working. We are supposed to do a full 3-way handshake for any port that is open. The fact that we're going to ignore that means that we need to have root privileges to be able to take better control of how the packet communication is happening. So we can see here we get the exact same results. It's the same machine. We're still talking over the TCP protocol. It's just that we've done a SYN scan instead of a TCP scan. And you can see that the time slightly faster on the SYN scan. This means that it can save you a lot of time when you're scanning large scale environments. Now, some of you, if you're just learning how to do this, if you're just learning about pen testing and the concept of port scanning, when you go and research stuff online, you may see this referred to as a stealth scan. Historically, it could be deemed stealthy. The reason why is because back decades ago now, it was harder for monitoring systems to understand that their computers were being scanned if the three-way handshake wasn't being completed in the TCP protocol. But we're in the 21st century, it's 2025. This is not stealthy anymore. There are other ways there are advanced flags we can use to make Nmap stealthy, but using a SYN scan is not stealthy in itself. Technology has improved. It is very easy for defenders and for software to be able to identify if a machine is being scanned, even though you are using the SYN scan. Okay, so let's have a look at the UDP protocol. Now, for UDP scanning, again, we need to escalate our privileges. And what we can do is we can type SU, the UDP scanning, and we can give it a machine. I'm going to give it a different IP address this time, as there's another machine I've got on my network that has a UDP service open. So what we're going to notice with this one is that if in your head you count to 5 while I'm speaking, you'll realize that you're going to finish. I'm still going to be talking, and our scan results aren't going to be back yet. That is because of the way UDP works. Because there is no three-way handshake, we don't get that immediate confirmation as to whether or not a port is open. The way Nmap is able to determine if a UDP port is open is that it will wait to see if it gets an error. So when we think about that fire and forget data, if the service is running, when we send it data, it shouldn't react because UDP doesn't. It doesn't confirm it received data. And we send it more data, it doesn't react. That's good. If the port is closed, what we should get is an error, and the computer should turn around and say, that port's closed. I don't know what you're sending data to me for, because that port is closed, and therefore I can't accept that. But because we're over a network, Nmap will send multiple attempts to every single port to turn around and check. If I'm not getting a response, is that because the port is open, or is that because I was supposed to get an error, but it got lost along the way? If I am getting an error, is that because the port is closed, or is that because maybe the actual packet got manipulated, malformed, something happened to it on transit, and therefore the open port couldn't understand what to do with it and sent an error message? So Nmap has to do a lot more work to be able to understand if a UDP port is open. There's a lot more communication getting sent. Okay, so we can see now our UDP scan is finished. It has taken over 1,000 seconds. That's longer than 15 minutes for this one machine to do, again, the most common 1,000 ports. And we have an output saying there is an open port and an open filtered port. When we look at the difference between TCP port scanning output and UDP port scanning output, whenever we get our output for TCP, ports are opened or closed. It's very binary because of that handshake. For UDP, typically we will see open filtered or closed filtered. Sometimes we get just a flat out open, but it's not uncommon to see open filtered, closed filtered. That's the most that you will likely see that output. And this is because of that lack of 100% certainty. Because of that lack of handshake, the computer cannot be 100% sure what's going on. So what this output is telling us is that Nmap got an error for every single port that wasn't 68 or 161. Now, 161 is SNMP, a simple network management protocol. When Nmap finds this open, it will send very specific data in a format that SNMP can understand, and it will get a reply to be able to confirm that this port is open. Whereas for DHCP, it doesn't do that. So what's happened is that when it's been looking at this port here, port 68, it has not received an error. It will have sent more data to that port and not received an error. But because it hasn't received any concrete evidence that the port is open, this open filtered is saying to us that either this port is open because I'm not getting an error, or there is something, maybe a firewall, in between me and that device is blocking the error from getting back to me. Okay, so that's why you might see open filtered. You should treat anything that's coming back as open filtered as, well, it appears to be open. Just to show you that that machine isn't just an insanely slow machine, I'm just going to run a really quick TCP scan against that computer. And you will see that this scan completes in a matter of seconds. Okay, there we go. Now, like I said, Nmap will by default scan the top 1,000 most common ports. You might want to have a look at every single port. Okay, the simplest way to do this is to do whatever scan that you would like to do, and then do -p0-. -p flag is giving a port range that we're interested in. Putting 0- means do every port from 0 to port 65535. We can once more turn around and just give it the IP address if I get it correct. And it will run a scan against all 65,000 ports now. Okay, as much as I say 65,000, I mean 65,535. This will take a little bit longer than the 3.89 seconds previously, but as it's the TCP protocol, it should also be relatively quick. This should take us less than 1 minute to do every single port on this computer, every single TCP port on this computer. It should take much, much less time than it did to do the most common 1,000 E ports. And there we go. We can see all ports on the TCP protocol have been scanned in just over a minute and a half in comparison to the UDP scan. This is really important to be aware of when it comes to scanning environments during a penetration test. Be aware you want to be able to kick off UDP scans first thing in the morning because they are going to take a while. You may turn around and reduce them down from the top most common 1,000, which is the default, to top most common 100 to specific ports that you're interested in. You may implement a range of advanced techniques to be able to turn around and speed up those UDP scans as you go through and get more experience. But for the minute, be aware this is how we do UDP scanning. We can see that we get different services open when we compare TCP and UDP. Now we understand how to identify target computers, how to run port scans against them, and identify open ports. Let's have a think about what we can do with that information. Now, when we look at this output in front of us, we can see that on this machine, I have two ports open, port 22 and port 1600. Nmap has turned around and told us that port 22 is used for the SSH protocol, that's the secure shell protocol, and that port 1600 is used by an ISSD protocol. No penetration tester knows what every port is. There are always going to be ports that you are unfamiliar with. There are always going to be services that you are unfamiliar with. It will depend what your experience teaches you, where your career takes you. Nobody knows what everything is. I look at that 1600 port, and I have absolutely no clue what that is. So what we can do is we can go through a process of gathering more information. We can do what we call banner grabbing. Banner grabbing is when Nmap will connect to an open port and it will ask the software, what are you? What software are you? What version of that software are you? It gives us an ability to get a bit more information about what is actually running on that machine. And we can do this really easily by running what we call a version scan. Now, when I run this, it's going to take a little bit longer because it's going to connect to the different services and find out what they're doing. We can see we get an extra column come back showing the version of software. So for our SSH, we can see that it's running OpenSSH 9.6p1. If I want to go and explore whether or not there are any vulnerabilities to that or how I can interact with it, I now know what to go and Google. We can see that port 1600 has completely changed. It's now showing as MySQL, and it's showing as MySQL version 8.0.40. This is because in the original scan, Nmap identified an open port and told us what that port is typically used for. As soon as we've interacted with it and we've turned around and said, okay, well, tell me what you are, tell me what you do, Nmap's been able to turn around and say, okay, it turns out it's MySQL, it's just running on a non-standard port. And this is why port scanning is effective. Because anyone who decides that they're going to hide a service on a machine by putting it on a non-standard port might think that they're hiding it from attackers, might think that they're making it so that people can't connect. But actually, it doesn't take much effort to be able to turn around and say, well, there's an open port. I'm going to try and ask it what it's doing, what it is. This is the concept of banner grabbing, and this gives us an ability to now turn around and say, hey, what information is this? What can I get from it? Understanding what software is running on a port is incredibly valuable because, again, it helps us understand that attack surface, that ability to think, what are the avenues of attack I have available to me? What I'm going to do is I'm going to show you how valuable banner grabbing is by demonstrating one last type of Nmap scan. So this Nmap scan is called a script scan. What it will do is it will take a series of scripts that Nmap has to try and extract more information. So if I turn around and run a script scan against our host here, again, it would help if I put the right IP address in. What's going to happen is instead of just identifying that a port is open, it's going to turn around and say, well, I'm going to connect and I'm going to try and extract potentially useful information. We can see that this has once more gone back to showing port 1600 is whatever ISSD is. If I run Nmap with a version scan and a script scan, because you can chain together these different scans, what I can do is I can help Nmap out. I can turn around and say, right, when you connect to a port, go and find out what software is running. And then based on that, then run some different kinds of queries. And we can see here, we get much, much more information coming back. Because this time, Nmap understands what the software is. It understands what's going on. If you want to be able to look at what these scripts are, you can just list the folder that they're in. It's user, share, Nmap, and scripts. They're referred to as .nse, Nmap scripting engine, and we can see there's a lot of them. A lot of different things that we can look for, that we can explore. We've got a couple over here that are based on FTP. I've got an FTP machine on my network. So let's again look at the value of being able to use a script scan. Let's do a standard port scan first. Okay, FTP is running. Now I'm going to run a script scan. And this time we can see we've got a lot more information. Okay, if we just focus on FTP for the minute, this time we can even see anonymous login is allowed. We've got a list of the 5 different files that are available there. So before I've even really done too much work, I've been able to use Nmap to identify a host, identify open ports, and then be able to go and try and get some more information, some more valuable data for me. And this all builds up to being able to understand the kind of power that Nmap has, the ability that we can use it to try and identify not just the ports, not just the software, but potential avenues of attack. That script scan is not infallible. It does not do absolutely every single thing that it could do. It is down to you to look at the output that you get through your scans, to have a think about what is most useful. If we take a look at a vulnerable Windows machine I have in this environment, we will start by doing a generic port scan. Okay? This was our machine that was only visible when we used sudo and an ARP scan. So I'm going to just really quickly get that going again. So what this is going to do is it's going to use ARP because I've escalated to root, meaning that I don't have to try the -pn flag. Okay, I could just as easily have ran the command pn st and then given it the IP address. You will see that the output that comes up will be exactly the same. The only difference is that when I've used sudo, the address resolution protocol, the ARP protocol, was used to check that the machine existed, and then Nmap port scanned the top 1,000 ports. Whereas for the second approach, Nmap didn't bother trying to figure out if the machine existed. It just started to try and connect to these ports as though they did. Both get me the same result, slightly different way of doing it. So let's take a look at the importance of thinking about how we approach these machines. We can, based on what we've just talked about, run something like a script scan against this machine. And this will gather a certain amount of information. This will be able to get some data from these machines to see, is there anything useful? Is there anything that I can do with these? Is there any way that it can guide me toward understanding how I might attack this computer? Okay, this has come back with some useful information. We just highlight information that it's got right in front of us. We've got an operating system here. We've got a computer name. We've even got a domain name. We've got some information that might be useful to us. If we scroll up a little bit, we can see other protocols have useful data as well. Okay, they've just got a bit of information showing that they're running, showing that something is on this machine. Now, a Windows 2012 machine that's unpatched like this one is vulnerable to Eternal Blue. But this output doesn't help us understand that. It just helps us understand the operating system. We can use those scripts in the Nmap scripting engine to be able to identify potential vulnerabilities as well. So if I just go back and have a look at that folder, we can see if we look over here, we're going to have to scroll up a little bit. You can see the sheer number of scripts as I'm scrolling. We can see that actually what we can do is we can try and use a range of SMB queries over here to see whether or not there are any known vulnerabilities, whether or not there are any of the big ticket vulnerabilities where it's really trivially simple for us to exploit them. And we can either execute one of these scripts individually within our nmap command, or we can execute a range of them. We can execute a subset of these scripts. So if I want to find out if that machine has any interesting SMB vulnerabilities, what I could do is a simple TCP scan to find the open ports. But I could also turn around and say, I would like to launch some of the scripts available to me. And I'm going to use the SMB vuln scripts that we just looked at. Now, I don't know what vulnerabilities might exist, so I'm going to use this wildcard asterisk, and this is going to turn around and get Nmap to try each of those different scripts to identify whether or not the machine is vulnerable to any of them. So it's going to go through things like Eternal Blue, and we can see the output's coming a bit faster than I thought. We've got this output here. The result for my script, this is the script that came back with notable data, and we've got a potentially vulnerable machine. So hopefully what this is showing you is that while we're talking about port scanning, and while we're using a port scanning tool, we've been able to use it to identify live machines on a network, identify what ports are open, and then be able to extract more and more and more valuable data, not just what ports are open, but what software is running on them, what data is potentially available from them, what kind of vulnerabilities might they have that I can now use against them. This is why port scanning is such a crucial part of penetration testing, because it gives us our first part of information. It gives us the ability to start putting pieces together and figuring out what are we likely to attack? How are we likely to attack? What is going on in this environment or on this machine? Okay, guys, thanks for watching. Don't forget to like and subscribe for more videos and guides on cybersecurity and pen testing.